Okay, here are the lesson objectives. Make sure you write them down. And let's get ready to begin. Okay, before we begin, let's learn a little bit about the circle and its parts, right? What is a circle? A circle is a set of all points in a plane that are equidistant from a given point called the center. So all of these points are the same distance, equidistant to the center, which is right here. That's the circle. Now, what is a chord? A chord is a segment whose endpoints are on a circle. So this is a chord because the two endpoints of this segment are on the circle. What is a secant? A secant is a line that intersects the circle in 2 points. So if you have a line that touches the circle in 2 points, you have a secant. A tangent is a line in the plane of a circle that intersects the circle in exactly 1 point. In this case, the tangent intersects the circle at this point right here. Notice that the diameter or any radius is perpendicular to that tangent line. A radius is a segment whose endpoints are the center of the circle and any point on a circle. And the diameter is the longest chord. It's the chord that contains the center of a circle. That's the diameter. And this one and the radius are important because we're going to be using those in order to find the area and the circumference of a circle. Okay? So learn those parts. Okay, in a plane, two circles can intersect in 2 points, 1 point, or no points. Coplanar circles that intersect in 1 point are called tangent circles. Example of that are right here. You see, these are tangent circles. They intersect at 1 point. Okay, coplanar circles that have a common center are called concentric circles. See, like you have a target. These are concentric circles, and then these are no point of intersection. See, there is no point of intersections. 2 points of intersections, 2 circles connect at 2 different points. You could have that. You have 1 point or no point of intersections. Okay. Okay, you have the area of a circle. It's the formula for it is pi r squared. So copy that down. It's pi radius square. And the circumference is pi times the diameter, or twice the radius times pi, or 2 pi r, right? Twice the radius times pi. That's your circumference. It's either pi times the diameter or twice the radius times pi. Okay? Okay, so we're going to be finding areas and circumferences of circle. Now, when this says approximate, it's the easy part, because that you just use the formula and put it on the calculator. When it says exact, just leave it in terms of pi. Do not try to reduce pi to a decimal, because pi is an irrational number. So leave it in terms of pi. Okay? Okay, the first one they give us, find the area of the circle right here that is given. They give us the diameter, which is 16 meters. Now, the formula for area of a circle is pi r squared. They said to approximate. So if we're going to approximate, we could use the calculator. We know that the radius is going to be half of the diameter. So that means the radius, and I'm going to write right here, the radius would be 8 meters, half of 60, right? So the area should be equal to pi, radius is 8, square. And remember, since this area is square meters, okay? So we put this in the calculator. We know this is 8 times 8 is 64 pi meters square, right? That's the exact, but they're looking for the approximate to decimal solution. Let's approximate it to the nearest tenth. So that is approximate. And I go to the calculator and I put 64 and put the pi. And I press enter, and it gives me that it's about 201 and 1/10 meters squares, 201 and 1/10. So 201 and 1/10 square meters. Okay, so that would be the approximate. This would be the exact right here. Let's take a look at the next. In the next, they give us that the area of a circle is 28 square centimeters, and we're looking for the diameter. So we know that the area is equal to pi radius square. So that means the area is 28 square centimeters, and we're looking for what is the diameter, right? So what we want to do, let us cancel this right here so that we are going to be working in just with the numbers. So we got 28 is equal to pi radius square. So divide by pi, so 28 divided by pi is equal to radius square, and then take that and square root it. So that means the square root of 28 divided by pi is equal to the radius. And then if you want the diameter, multiply that times 2. So this, we're going to take it and put it in the calculator. I'm going to go to the calculator, and I put 28 divided by pi, right? And actually I want the square root of that, so let's put that. Let's take this out. Hold on. Let's take this out, and over here I'm going to put the 28 divided by pi. Enter, and that will give me that is about 2.98 or 3, right? 3 is about 3. So approximately 3 is the radius, is approximately 3 centimeters. And we're looking for the diameter, so the diameter is double that. So the diameter would be 6 centimeters. And there you have it, and that's approximate. There you go. Now, when we're looking for exact, it means we're going to leave it as pi. We're not going to take pi away from that. So it says find the circumference of this circle right here. Circumference is how long is the circle, right? If I start here and I go around in a circle and I stop back at the same place, how long is it if I put it in a straight line? That's what the circumference is. And it says leave it in terms of pi. Find the circumference. So the circumference is pi d, or 2 pi times the radius. So the radius is 10 centimeters, so that means is 2 pi times 10, or 2 times 10 is 20 pi. You see how the diameter is 20 pi, you see right there? Okay, so that would be my circumference, and that is exact 20 pi centimeters. That would be my circumference right there. Now find the radius. They gave me that the circumference is 48 meters. We want to find the radius. So again, see, if the circumference is 48 meters, that means that we're looking for the radius. We got 2 pi r. So basically divide this by 2 pi. So take that, divide it by 2 pi. Take this, divide it by 2 pi on both places. This cancels, and it leaves me that the radius is equal 48 divided by 2 pi. Now, what is 48 divided by 2? Well, 48 divided by 2, that's 24. So the radius is the same as 24 over pi. Okay? 24 over pi. So that's would be my answer. Okay, that's the actual measurement, and this is in meters. There you have it. Okay, here's a central angle. Here's some other definitions. What is a central angle? It's the angle whose vertex is the center of a circle. For example, right here, let's call this angle 1. This central angle right here, that's the central angle, angle 1. We could call it also angle CDB. Angle CDB. That is a central angle, see? Right here. Now, what is an arc? An arc is a segment of a circumference of a circle. For example, this right here, from C to B, this is an arc. Now, what is the measurement of the arc? Well, the measurement of the arc is the same as the measurement of the central angle. And what is a semicircle? Well, a semicircle is half of a circle's circumference. So from A to B, right here, that would be a semicircle. See, it doesn't matter whether I go on top or the bottom, it's a semicircle. Now, when we're talking about a minor arc, an arc that subtends a central angle of less than 180 degrees. So let's talk about angle 1 right here, this central angle. Well, the arc that contents it is arc CB, which is this one right here. Okay, and the way you name it is you just put CB and put an arc on top of that, and that's arc CB. And this is a minor arc because obviously it's less than a semicircle, it's less than 180 degrees. Now, a major arc, let me change colors for that. Major arc would be if I'm going from C to B, right? From C to B, but this time instead of going the short way, which is less than 180, I'm gonna go like this. Look. I'm gonna go around, but the other way. And that right there, oops, I went from C to C, sorry about that, to there. So this right here, that's a major arc right there, from C to B, but this time going the opposite way. And when you're naming it, you need to use 3 points. So C, I start at C, I went through point A, and I ended at point B. So here is a major arc. I just put an arc on top of it, okay? So pretty simple. Okay, here, you try these ones. Name it. And they want to name the arc for angle 1. Make sure you pause the video, try to work it, and then come back to the video and see. Arc for angle 1 would be what? I'm looking at angle 1 right here, so the arc would be LK or KL, doesn't matter, right? So I'm gonna say arc LK. That's the minor arc, right? That's the minor arc. The major arc for that one, it would be LIK or LJK. Doesn't matter which one you use, so I'm gonna use LIK. Just you have to use 3 points. L where I started, points where I go through, and then where I end up. LIK, that's the major arc, and that's arc LIK. Okay, so here we are trying to find what a central angle is formed by arc GH. Notice arc GH is a minor arc. It goes from here to here. Okay, that's a minor arc. And it should be a curve, right? Okay, so that's a minor arc. That would be angle 1 because it contends to its central angle. So that would be angle 1. Then the major arc, you have IGJ. Let's use another color, IGJ. So it goes from here, goes through G, keeps going all the way to J. And notice the angle that is formed by that major arc, it's angle 3. Angle 3, see? It's this one right here, because its minor arc would be IJ or JI, so the major arc is IGJ, so it's where it started and where it ended, IJ. So if you want to know what angle it contends, then notice is these two right here. So that would be angle 3, okay? Alrighty. Okay, the next part is finding the measurement, okay? So there is a difference between the measurement of the arc and the arc length. When we're talking about the measurement of the arc, we're talking about degrees. When we're talking about the arc length, it depends the unit of measurement that you're using. It could be centimeters, meters, miles, whatever. But there is a difference between those two, so make sure you write a note. There is a difference between arc measurement is not the same. Is not the arc length, okay? Arc measurement is not the arc length. They are different things, okay? So here, find the arc measurement. So basically, if we're looking for this arc measurement, we're looking for what is the measurement of this arc right here. Well, we know that a circle is 360 degrees. So we could take these two measurements right here. There are these two central angles that they gave us. And it says, well, that's 130 degrees plus 125 degrees. That gives us what? 255. We'll take that number and subtract from 360, and that will give you the arc measurement, which is the same as the central angle, right? First, you get the central angle. So 360 minus 255, and that will give you your central angle, which is the same as the arc measurement. So that's 10 minus 5 is 5. We got 0 over here, and 3 minus 2 is 1. So that means this is 105 degrees. So that means the arc measurement is also 105 degrees, okay? Let's take a look at this one. Okay, we know here we have a semicircle, see, because this is a diameter. So this angle right here must be 180 degrees. Now notice these two diameters right here, they form vertical angles. So we learned that vertical angles are congruent. Therefore, this is also 42 degrees right over here. So now we could deduct that this arc is the same as the central angle. So we have 80, so we need 100. So 100 minus 42, 100 minus 42, right? That's 58 degrees. So that means this right here is 58 degrees, and that completes the 180. Therefore, this measurement of this arc, which is this one right here, let me highlight it. This arc right here, that's 58 degrees, okay? That's 58. Now, the measurement of the arc length, we're talking about what is the distance, okay? The distance is part of the circumference. When we're talking of measurement of the arc length, it's part of the circumference, okay? So let's talk about that. Okay, so we're talking about the measure of the arc length, right? It's basically its corresponding central angle. Let's say we have this circle right here, and I ask you what is the measurement of arc CB. Well, it's gonna look something like this. It's gonna say M of arc CB. Basically, let's suppose this is 80 degrees, my central angle. Well, the measurement of arc CB, which goes from here to here, right, that would be also 80 degrees. So the answer would look something like this. Okay, so that would be the measurement of arc CB. Okay, but when we're talking about arc length, that's a whole different thing. Let's suppose the arc length is the actual distance, not the degrees, it's measured in distance. Let's take this circle, for example. It gives me that it has a radius of 10 centimeters. That means the circumference would be 2 pi times 10, right? 2 pi times 10. That's the whole circumference. That would be 20 pi centimeters. That's the whole thing. This is this whole thing. Let's suppose I divide that in quarters. Let's suppose I divide that in quarters. In fact, let me get a line better than that, because my lines I draw kind of crooked, you know. So let me help with something like this. And I am trying to make it straight, so bear with me here. Okay, so I divide it into quarters. So basically this would be 1/4 of 20 pi, correct? If I want from here to here, the length would be 1/4 of 20 pi. So let's say I want it from here to here. That would be 1/4 of 20 pi, which, what's 1/4 of 20 pi? 5 pi, isn't it? This would be 5 pi, this would be 5 pi, this would be 5 pi, this would be 5 pi. See how that works? So 5 pi, 5 pi, 5 pi, 5 pi, that would give me 20 pi. Centimeters, right? That's how long this part, if it's 1/4. But what if it's not 1/4? What if it's has a measurement, and I know that, let's say I have a line right here like this, and this measures 30 degrees. Well, then what would this measure? That's the question. What would be the arc length from here to here? What would be the arc length from here? Show you. From here to here. What is that arc length? Well, we could find that because we could use ratios or proportions to find that measurement, right? We could say that, well, we know that 30, because this is 30 degrees, 30 is to 360, which is the whole circle, right? 30 degrees is to 360 degrees, which is the whole circle. As we know the measurement of the circumference, which is 20 pi, well, what is x to 20 pi? So that's what we're looking for. So what we do is we cross multiply, right? So that means 360x is equal to 20 times 30. 2 times 3, that's 6. Add 2 zeros, right? And that would be pi. We are solving for x, so divide that by 360 on both sides. That means that x is equal to 600 divided by 360, and you could put that on the calculator and you could leave it exact. Yep, to 330, sorry about that. 360. And notice it's 5/3, right? So basically this is 5/3 pi. There it is. So 5 pi over 3. So this is what this would measure. 5/3 pi. 5/3 of pi, which is, you could approximate that, but I am just gonna leave it in basic exact measurement, and this would be centimeters. Okay, and 30 degrees, the arc on this one particularly would measure 5/3 pi. Okay, there is another way you could do this, that if you don't want to use proportions, I like using proportions, but if you don't want to use proportions, you could use a formula. And here's how we derive the formula. Give me one sec right here. So I'm gonna take this, actually I'm gonna take this whole thing. Move it right here. I'm gonna take these and move them right there. Oops, oops, oops. Right, and it gave me that using the proportion. Now let's say we know that 30 is to 360 times, we could take that, times 2 pi r, which in this case was 2 pi 10, right? And basically that's gonna give me, that is the same as 1/12, because 30 over 360 is 1/12 of 20 pi. And if you take 1/12 of 20 pi, that would give you, that is 5/3 pi, or 5 pi over 3. Okay, so basically here is the formula. The formula would be, let's say if I want any angle, let's call this theta. So the formula is theta over 360 times 2 pi r. And that's the formula for the arc length. So theta, where theta is the angle that you're contending, or whichever angle or arc measurement that you're looking for, over 360 times the circumference. Okay, that's the formula. So let's try it. Let's try some. Here we go. Approximate to decimal solution. So that's beauty, that is, you could put that on the calculator. They give us this one right here, and this approximate. So this whole thing, the radius is 16 miles. The radius is 16 miles. So that 16 mile, it's talking about the radius. The radius is from here to here. Now that's my circumference, would be 2 pi 16. The question is, what is the arc length from here to here? All right, so we could use the formula, since the formula was theta divided by 360 times 2 pi r. Well, here we go. So 45 divided by 360 times 2 pi 16. And you could put this on the calculator, and it will give you that it is approximately, and let's put it on the calculator. All right, let's get a clean slate. Boom. So that would be 45 over 360 and this times where's the times, 2 pi 16, right? And I put that on the calculator, and it gives me that is approximately 12.6, rounded to the nearest tenth. It's about 12.6, and this is in miles, about 12.6 miles. 12.6 miles. Here the radius is 16 miles. What is the arc length? If theta is 126 degrees, well, basically again it's the same thing. Theta is 126, so 126 over 360 times 2 pi 16, right? In this case, instead of 45 degrees, we have 126 degrees. So again, you put it on the calculator. That's 126 divided by 360, and that is times 2 pi 16, and we get that is approximately 35.2. So that's approximately 35.2 miles. Neat. Now, what are they talking about when they say exact, leave it in terms of pi? Now we're talking about the major arc. See that? They want the major arc. How long is this right here? So basically, if you want the exact measurement, we have that this, just leave it in terms of pi. So the formula was 240 or theta over 360 times 2 by 12. So 2 times 12, that's what? That's 24 pi. 240 over 360, we could reduce that. Let's go look. 240 over 360. That gives me, that is 2/3, right? So that's 2/3 times 24 pi. Now 24 times 2 gives you 48, and 48 divided by 3. So let's take that. I think it's 14, but let's make sure. 48 divided by 3. Oh, 16. So it's 16 pi. That means the actual measurement is 16 pi. 2/3 of 24 is 16 pi. Okay, you leave the pi alone, that gives you exact measurement. Let's try one last one. Let's say the diameter is 24 centimeters. And you have a zeta, it's 60 degrees. Okay, and what is the arc that contains that central angle of 60 degrees? Well, again, that would be 60 divided by 360 of 2 pi r. Since they gave me the diameter, half of the diameter is the radius, right? So that's times 2 pi, and 24 divided by 2, that's 12. Right? Also, we could have used pi d, so 24 pi, right? So 6 divided by 36, that's 1/6 of 2, or 24 pi. So that's 24 divided by 6, that's what? 4 pi. So that means that's 4 pi, and let me get that units. That would be centimeters. And there you have it. All right, so from now on, just let's go do the exercises, practice, so that you learn this very well. See you in class.